Hello everyone, this is Miss Chelsea, and today we will be discussing the periodic table trends. Our question of the day is, what are some of the patterns or trends on the periodic table? Our standard for today is SC1F. Use the periodic table as a model to predict the relative properties of elements based on the patterns of electrons in the outermost energy level of atoms. For example, atomic radii, ionization energy, and electronegativity. Now, a trend is a property with a pattern. So the periodic table can tell you a lot about the properties of an element if you just know how to read its secrets. Our first example of a trend is the atomic radius, which is half the distance between two nuclei of identical atoms bonded together. Atoms don't really have defined edges, so this is how we judge their size. We take this distance and cut it in half. Now, fluorine is actually the smallest element on the periodic table. It is in the top right-hand corner of the periodic table. The largest will be on the opposite corner, so the bottom left-hand corner. Now, the first ionization energy is the energy needed to remove the most loosely held electron from an atom, its valence electron. The first ionization energy is for the first electron removed, and the second ionization energy is for the second electron removed. Keep in mind that the smaller an element is, the more closely it's going to hold its electrons, so the higher the ionization energy will be. That is why fluorine has the highest ionization energy. The ionization energy follows the opposite rule as the atomic radius. Electronegativity is a measure of the attraction for the electrons in a bond, so how well an atom holds on to its electrons. Between any two atoms in a bonded molecule, there will be a tug of war over the electrons in their outer shells. Now, smaller atoms tend to have electrons closer to them, so the electrons are closer to the positive nucleus, and therefore they are more likely to be attracted to that atom. That means there is higher electronegativity for smaller atoms like fluorine, so the ionization energy and electronegativity have the same trend. Metallic character, on the other hand, is how willing an atom is to lose electrons. Only metals like to lose electrons, so this is how we technically define a metal. Notice how the metallic character is the opposite of ionization energy and electronegativity. That's because atoms with less attraction to the electrons are going to more easily give up their electrons. Now go ahead and try the show what you know questions for this section. Now let's have a look at nuclear charge and shielding. Our second question of the day is, what are the primary differences between the Bohr diagrams for fluorine and chlorine? Notice how when you go down a group on the periodic table, the number of principal energy levels increases. The interior electrons, sometimes called core electrons, will block or shield the attractive forces between the nucleus and the valence electrons because there is a repulsive force between the electrons in the outer shell and the inner shell. The more core electrons there are, the stronger this shielding effect is. So trends going down a group are dictated by the decreased attraction between the valence electrons and the nucleus due to shielding. This is why the ionization energy is smaller the further you go down the group. Now, if you go across a period, the number of protons will increase, but the number of principal energy levels stays the same. So the repulsive force doesn't change, but the attractive force increases. Let's just look at the second row. Lithium has 3 protons, beryllium 4, boron 5, and carbon 6. That means that as you add electrons to the same shell, they are going to be more closely attracted to the carbon than the lithium because there's more positives to attract them. Now, truly, electrons are moving around the nucleus so quickly, the nucleus is really attracted to and pulls on the electron shells, like we just said. The more protons there are to pull on the shell, the tighter the electrons can be pulled in, which is why sodium is bigger than chlorine. Trends across a period are dictated by the attraction between protons pulling on electron shells. Now, we are done for today. Go ahead and try the second half of the Show What You Know question.